Okay, this video series is on the safety of linear magnetism and superconductivity. My name is David Puchta, and I'm going to introduce to you the amplification of gravity over superconductivity and superconductivity over electromagnetism. I am holding this extremely red hot electrode, okay? Watch. You see the hole? Now, please grab the temperature gun. Go ahead and start the temperature gun on the electrode. You push the red trigger and the trigger at the same time, and you aim the laser at the electrode right where it's hot. You see the temperature of the electrode? Watch the temperature of the electrode. Okay, now you see the electrode. It's cherry red hot. What's the temperature of the electrode? Shine it on the electrode. Right there. It says 400 degrees. Now bring the temperature red laser up toward my fingers. As he's going up to my fingers, you see what temperature the electrode is? It says 190. That's not true. It's the near magnetic infrared signature that's fooling the temperature sensor. He's right on where my fingers is. Now, take it off the IR, take your finger off the thumb off the button, and pull the trigger. Push the button, pull the trigger. Let go of the button. Okay, now the infrared is off. Now look at the temperatures of the electrode, 700, 800 degrees. But look it up here next to my fingers, 154 degrees. That feels about right. It's still comfortable to hold, otherwise I would not be holding it with bare hands. Okay. Now, how do we calculate this? This is how we do it. This is a temperature soak. It's a water bed and a water press. We take the cherry red hot electrode, stuff it in here. Okay? Then clamp it. So we know, bam, what the soak is. Extremely calibrated temperature sensors on this potential, which is smaller, which would be the positive potential, and this potential on the negative water would be the negative potential. Then we take a third potential across an ohm meter to see if the brunt, the brute force of the water, to see if we've energized the water. This is why. Now we take a pH meter And by dilution, we've taken this pH from water, and it's up over 14. It's 26.6 pH, almost 27 pH. The same exact near magnetic frequency of two things, gravity and hydrogen deuteride. Okay, now this is to show you how safe the power is. Here's the electrode. Okay, now the coating is superconductivity. However, this is the machining of this electrode a couple of minutes ago so that I can get a clean arc for you. You notice how one side of the metal is shiny off the lathe and the other side is not? Because we've changed the magnetic ordering in the condensed matter from carbon to graphene. Otherwise, there is no way I can be holding this piece of metal. That would be impossible. Now, on to part 2.